Hey everyone, it's been a while since I've made a video, and in this video you will be seeing why. I have been making some massive changes to this toolkit. So this is by far the largest update I've ever done, so much so that I'm calling it version 3.0 of the toolkit. And you won't actually be seeing that much in terms of flashy new features. This is more of an overhaul or a refactoring of the underlying code, which will make it a lot easier to add certain kinds of features. It makes several things in the toolkit a lot more modular and easier to swap out and modify, and will also make it possible to modify the toolkit in ways which was very tricky to do before. So there are some large, like main overhauls and changes and additions of new systems that I will get into, but there are also just huge amount of minor tweaks, fixes, optimizations, refactoring all across the board. So almost any blueprint that you look into in the toolkit, if you compare it to the last version, you're gonna see some changes. So what this means, of course, is that previous tutorials that I have, many of them will be somewhat outdated now. Some of them will you'll be able to follow more or less like before, but some of them will be changed completely. So in this tutorial I will be going through the largest changes, and I will also give some quick examples of how you can work with these new systems. And then the plan is to make new tutorials where I go more into depth later on, but I'm hoping that this tutorial will give developers enough of a starting point to be able to work with the new systems, to understand the new flow. And then until I make the new tutorial videos, and of course even after them, feel free to always ask me questions in my support thread. I also now have a Discord for the toolkit, which will be linked in the description, which is quite active, and you can get in there if you want to ask some more minor quick questions about the toolkit, or also if you just want to chat. But for larger questions where you need to sort of paste a lot of blueprint code, and maybe I will need to reply with examples of what you can do and so on, then the support thread on the forums is a better fit for that. Also a big shout out and thanks to some of the developers on the Discord who have helped inspired me and give me ideas for how to improve the toolkit. Especially Flux and Necron on the Discord have been really helpful in providing feedback. Okay, so without further ado, let's get into the new features. Now let's start with the largest change first. One of the major changes that was made in the toolkit a couple of years ago now was the addition of the action system. And the action system, it allows you to queue what are called actions, so that you can sequentially play stuff like animations and anything that is really shown to the player. And it created this clear distinction between gameplay logic, which happens instantly, and then things that are shown and displayed to the player, which happens asynchronously and in a linear queue. Now this addition created a lot of new options for things you could do, and it made many things easier, and it made networking easier. And yeah, I go into more of the benefits in my action system tutorials, but it is also a bit clunky and a bit awkward to get used to. You needed to add sort of interfaces to actors, and you needed to pass structs through them and split those structs, and then remember sort of the names that you're passing into some macros when you manipulate them later, and you have to remember which variables that you're passing into an action or represent which variables. So you have to keep track of a lot of things, both in terms of variables and also in terms of where are you calling the actions, where are you ending the actions, which could quickly lead to some problems with actions ending too early, and you got some weird results because of that. I mean, it was perfectly possible to learn to work with this system, but it was always a bit more clunky than I wanted it to, and also had some limitations. So I chose to overhaul the action system more or less completely. You'll still be able to work with it in much the same way, but it should be a lot simpler. And if you go into the core folder of the toolkit now, you'll see that there's a new folder here called Actions, which holds a lot of the actions that are used in the toolkit, though there are more actions in the example maps as well. So to show an example of how you would queue one of these new actions, previously you would use a macro for this, and now you do it differently. So if we go into one of these units, I can show a quick example. So going into unit anim and then overriding select actor, just calling the parent function, and then I want to queue something when this actor is selected. Say whenever an actor is selected, I want to spawn a particle emitter, and there is an action for this. As you can see here, you have the action, let's see, spawn emitter. So now we actually spawn an actor for an action. So actions are now represented by actors. So this was the action spawn emitter. And if we compile it like this, we'll get an error. So we'll need to split the transform, then we can compile. And then we can select an explosion and then a sound. Let's do the fire blast. And we want a transform. And do I want to use the unit transform here? No, I actually don't. I want to use something called a puppet. And what the puppet is, I'll get into in the next feature that I have added. But let's get the transform. And now, if we hit play, you can see that when we select an actor, we get this little explosion at their feet. So this is working. So you can see now that benefits of this is that we can define within the action here the names of the relevant variables we want to affect. So it's not like previous actions where you just had, names like float, and you had various arrays of these variable types that were just named after the types they were. Now we can actually define the names, which is, of course, makes it a lot easier to keep these things, keep track of what we are modifying. So that is quickly how you would queue an action. Like I said, I will go into this in more detail in a dedicated tutorial, but I'll just give you the quick version. So let me also give the quick version of how to add a new action. So as an example action, just let's make an action that doubles the size of a unit whenever it is selected, just to have something similar to what we're going with. So let's start with the BP action and create a child blueprint class. And we'll just call this BP action double size, doob size, double size. My L key has fallen out of my keyboard. There we are. Okay, that's not how you write double, but yeah, we'll do this quick. So I'll just delete this for clarity. So we're in the event graph of the action now, and you can modify actions in a lot of ways now. Since they are an actor, there's a lot more flexibility in having actions work in different ways and refer to other actions and so on. But yeah, I won't get into any of this now. Let's just show how to make a basic action. So what you would do is to take the play action, the event play action here, and you don't need to make a call to the parent function or anything for this. And here we can set all the stuff we want to do within the action. So we want to double the size of a unit. And much like actions before, we want to make sure that we pass to this action anything that we want to modify in it. And also, like before, we don't want to have anything within the action that actually modifies gameplay code that's relevant for gameplay, like game logic. So this will be for visualizing, showing stuff to the player. Anything that we want to have queued that happens sequentially after one another and which is shown to the player should generally be within an action. So the stuff we want to pass in here. So we want to have this unit that we want to double in size. So we will add a variable here, and this will, and like I said before, we're not actually using the unit, we're using the puppet of the unit, which is now the in-game visualization of a unit, while the unit is more like an abstract code class now. This is the next feature, like I said, I'll get into after talking about actions. So I'll just call this puppet, and puppet can be actually any sort of actor. So this will be an actor reference, and for any variable we want to modify within an action, we want to make it instance editable and expose it on spawn, so that when we spawn this action we can modify this variable. And if we have a network game, we also always want to make them replicated. So we get this puppet, and we can set let's see, scale. So let's set the actor scale 3D, and maybe the relative scale. Let's just set the scale directly. And then we want to have a new scale. So I'll just promote this to a variable scale. And like now we've added a new one, so we need to make it instance editable and expose on spawn and replicate it if we have a replicated game. And we're good. And after this we want to call then end action. And that's all we need to have a working action. Now let's set this action up here in this anim. So we'll just, we'll keep the explosion, and we'll spawn a new action, and this is our the action double size, dual size, as I call it. Like, this mechanical keyboard is not the greatest. Okay, and so we have a puppet. We use the same puppet here as before, and we set a scale, so I will set it as a doubling in size. And when we now hit play, we see that we double in size when we select the unit, and we still have our explosion. It's always set to 2, I think, so when I select again they will just stay at this size. So yeah, so you see that it's simple enough to add a new action, and it's much easier to keep track of the variables that we are actually using than it used to be. When the actions are spawned in the event begin play event of the actions, they are automatically added to the action manager, into the action queue, which is an array of actions which are then played sequentially by the action manager. And after the action has been played by all clients, they will be deleted, so there will not be a lot of actions that are being spawned and just staying there in the game and taking up memory. So they are deleted as soon as they are no longer needed. But yeah, that's a pretty quick rundown about how the new actions work. So like I said, lots and lots of stuff you can do with them now. The new actor-based approach offers a lot of flexibility, but yeah, I'll get into that in a later video, like I've said. So next, let's get into the puppets, which I have been hinting to. So what are those? I've been mentioning a bit already, but if you go into units now, you'll see that some stuff is different here. You will have the units that you're used to here, but you'll also have a folder which is called puppets. Puppets are how units are visualized in the game. So units now, they handle game logic, but they are invisible, even though they technically have a transform since they are actors. They are not meant to be seen in the game, so they're more to be thought of as pure data objects. And so the reason for this, well, there are several reasons I made this change. But one of them is that since we have this action system in the toolkit where you have game logic that happens instantly, and then you have the actions that are queued and happens asynchronously, and units, they kind of existed in between these two, so they handled sort of game logic and so on, since they were important in, you know, knowing their health and being there to activate abilities, etc. But they were also how they were seen in the game, and it caused some parts of the toolkit to be a bit more awkward than it should be. So an example is if a unit kills another unit, game logic wise that happens instantly, right? Because everything happens instantly in the game logic. And then the actions would be queued that showed one unit attacking and killing another unit later on. But to be able to do this, I had to make sure that when the unit is killed, it's not actually destroyed. We need to make sure that it's kept around so that it lives long enough, or the actor exists long enough, that we can show the animation of the unit being killed, etc. And that's one example, but there were other ways in which this was a bit awkward. So therefore, or that's one of the reasons I have then split units into units and puppets, because then it's fine to just kill off the unit in the game logic, and then the game can easily treat that unit as destroyed. But the puppet can still stay around and asynchronously show that unit, or really the puppet, dying at a later point. There's another major reason why I changed so that I'm using puppets instead of these units, and that's based on a frequent request and something that I long wanted to add, which is that units in previous versions of the toolkit, they were actors. And because of that, they cannot be characters, because actors and characters are different C++ base classes in Unreal Engine. And that means that you can't add the sort of components and code contained within characters to actors at a later point, because they need to inherit from the C++ character class to be able to do this. And this made it difficult to make use of sort of the movement code and these things within the Unreal Engine character C++ class if you wanted those. Now with puppets you can change this. So you can see that within units you can change the puppet class here. So I might, for instance, change this into one of the heavy unit here, and you can see that within the world outliner the puppet is changed here. And these puppets are not actually the ones that are used in the game. These are the ones that are used for just displaying when working within the editor here. But a separate puppet, which is not a child actor of the unit, but is a separate actor, is spawned when the game is started. And this is, like I said, to keep these separate so you can destroy one and keep the other. Now I won't go into detail in how to create puppets and so on in this video, as this is intended as an overview, but where you want to look is to go into the puppets here, and you want to base your own puppet probably either on the actor puppet here or the character puppet here, depending on the sort of unit you want to create. And you can see within these puppets that they have this sort of component, and they also have an interface, this puppet interface, and a HUD interface, and these are then used, these and this component are used by the unit to communicate to the puppet. And animation, most of the animation then is handled by this animate puppet interface event, which is defined within the puppet interface. And this interface is passed into the animation blueprint of this puppet, which in turn handles the actual animation. So if we go into the animation blueprint of the unit here, you can see that also this animation blueprint has this puppet interface, and then it receives in this animate puppet event, you have these gameplay tags here. You can add more gameplay tags, and then it handles then the various animations within this. And then after the animations are done, they signal that this animation is ended, send this back to the puppet, who then receive these events. And then they will call interface events, which generally are used by actions, so that the actions know that an animation is over and that the action can end or proceed. So yeah, lots of information a bit quickly there, but I will, like I said, I'll get more in. I'll make videos going specifically into how to create puppets and units in the future. Until then, just feel free to hit me up in the forum support thread or on the Discord to ask any questions there. But look into the actor puppet and the animation blueprints and see if it makes sense to you. Okay, so that's two big features down. Let's move on to the next. So next I will talk about what I'm calling Grid UI. So you'll find that also in core within this new grid UI folder, and you'll see here you will notice that a lot of the different decals and materials and so on that are used for showing various stuff on the grid is displayed here. And you'll also see these various grid UI actors, and what these are actors that handle all the different UI elements that will be user interface elements that will be displayed on the grid. So something like tile markers showing movement ranges and showing the current unit and so on. So in older versions of the toolkit, this was done within abilities. So each ability would handle their own UI, and they would sometimes they would get how they were visualized from defaults defined within the grid managers, but they could be overridden within the ability itself, and it was, yeah, like many things, a bit clunky, and sometimes you would have to do the same sort of UI in different sorts of abilities that you would duplicate, you would have to inherit, and so on. So with this new setup, it can be a lot more modular, and you can swap it out a lot more easily. So if we hit play here, you can notice, yeah, we still have these actions going, but that's fine. You can see that we have this standard setup with meshes for this hex grid at the moment now, but we can then go to our grid manager here, and we can find the grid UI class, and we can swap this out. So if we want to use decals instead, we can use the grid UI decals hex. And now if we hit play, we can see that maybe it's not that obvious if we haven't been working on this toolkit for years, but we're using decals instead of meshes now. In this map it's more obvious. If I'm moving, you can see, yeah, that the decal is sliding here between these gaps. But yeah, I can use something more obvious than that. I can change it to then the square grid UI, and you can see now that we are using square meshes instead of hexagonal meshes for this. So this is one way to do it. We can define it within the UI class of the grid manager. You might have noticed something there earlier, by the way, which I just realized. When I'm moving over here, and you can see an explosion over there, and this is the sort of issue that you can see quite often when working with the action system, and that is since we queued the action of placing the explosion here when the puppet was still here at this point, and then when he had reached this point, then the next action is going to play, which is this action which was queued here, which is why we're seeing the explosion over here instead of over here. So really, if we wanted the explosion to be on the puppet, we should have passed a reference to the puppet into the action and then placed the explosion on the puppet. But yeah, that's the sort of stuff I will go more into in the updated action system tutorial. But yeah, just if you're wondering why the explosion is appearing over here. But yeah, that aside, we're still talking about the grid UI. So this is one way, defining it in the grid UI, or in the grid manager, this grid UI class variable here. This will set it as like the default grid UI you're using in your abilities, but you can also set it specifically within each ability. So the units here, they are using their default ability is move attack. For this guy, let's change it to just the move ability instead, and let's open this ability, and then we can, within this ability, we can set an override. So let's override this to instead use then the square grid UI, while for our grid manager we will be using the hexagonal grid UI. And then we need to make sure, yeah, he is using the movability, right? So if we now switch to this guy, you can see that he is using the square meshes for the UI, while these other guys are using the hexagonal meshes instead. So like I said, grid UI, they can be found within the grid UI folder in core here. They're relatively simple to modify. So if I create a child blueprint class of grid UI here, yeah, let's just keep the name child. And you can see here that it has, you can change the appearance here pretty easily. So if we want the hover marker here and we instead want to make this look like a crate, and yeah, we're gonna need to compile shaders again, I guess. But then now if I am using for the grid UI here, let's see, and I will use child instead. If we hit play, now we have this crate for a hover marker. I don't know why we would want to have that, but yeah, whatever you want to do. So that's one place you can modify it, and you can also modify, you know, the move marker mesh and the range marker mesh and so on. So just changing these basic things, pretty easy. But you can of course get more creative and override, you know, these various sorts of functions and events for spawning markers, etc., and override these functions and so on if you want to do something more fancy. But I guess I'll try to cover that as well in a later tutorial. So there's gonna have to be a lot of new tutorials. Well, and I just got a daughter, so it's sometimes difficult to get the time. But like I said, until then, or even after then, just ask me if you need any help. But yeah, so those are 3 of the big new additions. I'll have another major one, or quite large one, I'll go through before going to some more minor additions. So this next one I'll cover very briefly, because to be able to explain it in any depth at all, I'd have to go really in depth, I think. And this is that pathfinding is now handled by these separate pathfinding objects. While earlier all of that was handled within the grid manager, and now this is made so that it's more modular. It was, again, I've been saying this word again several times, but it used to be a bit awkward to add new sorts of pathfinding types. You had to add new functions for it within the grid manager, and then you need to modify this sort of central hub function and add this new pathfinding type to a switch statement and so on. So it was more of a hassle than it should be, and especially if you wanted to modify pathfinding quite heavily. If you did anything more than a few simple tweaks, it was very difficult. So now with these pathfinding objects, it's simpler to make new custom pathfinding types. So you can override sort of the functions that are handled within the pathfinding. So pathfinding, it starts with a sort of setup which is called from the grid manager, and then you have the main sort of pathfinding loop here, where the pathfinding goes through adjacent tiles, add them to the pathfinding map variable, and keeps going until it's out of moves. So you have various loops within here, and you can override, and this is particularly the function you will want to override in many types of custom pathfinding. So yeah, I'll explain this very briefly if some of you are feeling adventurous. So pathfinding, it starts at a unit or at a specified index, right? When you call the run pathfinding function within the grid manager. So it starts there, and then it looks for neighbors, and it does that by looking at the grid edges, which is a map variable in the grid manager, which holds like which tiles are connected to which other tiles. So then it looks through all the edges, it sees, okay, do I have enough move to go there? If so, then these tiles are added, and then these tiles, they then start to look around themselves to see, okay, what tiles around me am I connected to, and have enough move to go to that have not already been searched by the pathfinding. And then it keeps going like this. So any time it then looks at its neighbors, it wants to check, okay, is this a valid tile? And in this normal pathfinding BP path, you will see it doesn't need to check this much. All it checks is, okay, is the total cost of moving into this tile lower or equal than the move value that I have here? And if so, then it wants to add this tile to the pathfinding, and it is added. So to see how this works, if we go into one of our units here, let's select all of our units, why not? And then if we search for their pathfinding, you will see that pathfinding type is now a reference of these pathfinding objects. And if we have this regular BP path and we hit play, we will see that they are not able to move through other units. But now if I change this to the pass through friendly type of pathfinding, yeah, we're still using this box, then you see that we're able to move through other units. And the reason for that is that when this pass through friendly version, you can see that it's overriding this add tile if valid. And the difference here is that in BP path, if this tile that's being added, it contains a unit, then that tile is not added to the open list, which means that it will not be considered for further pathfinding. While in this pass through friendly version, you see that we are adding it to the open list. So this is how it overrides this particular function. You know what, I've gotten this far. Let's create a super simple pathfinding object as well. So let's see what we can do. Yeah, let's make a pathfinding type where we only add tiles if they are further along the x-axis for where we started. Let's see if that works. So I'll just create a new child blueprint of this path here. And then I want to override one of the functions. I want to override the add tile if valid. I want to keep the parent function. So I'll just connect all of this up. But I don't want to add the tile if it is not further along the x-axis than its parent. So we can do that. Then I have a reference to the grid manager. And I can get the grid edges, now I mean the grid locations, and we'll find the location of the parent index, and we'll find the location of the edge index, and we will check along the x-axis here that the let's see, so this was from the parent, so the x of this is lower than the x of this location, and we'll add a branch, and this won't look pretty, but yeah, just to illustrate. And so this is the path child. Let's take all of these, change this to path child, and yeah, there we are. We can only move if it's further along. This looks more and more stupid every time I hit play, but yeah, hopefully you're learning something. And so we can only move along the x-axis. So yeah, we created a new form of pathfinding. Hooray! Right, okay, so those are the big four in terms of new features that I've added. So many of these features, they will impact many other blueprints, of course, because these are such fundamental systems within this toolkit, such as how UI is handled, how actions are handled, particularly how pathfinding is handled, and so on. So, like I said, if you go into any blueprint and compare it to older versions, you will see changes. Some of them will be changed massively, some will be changed less so. There are also some features that I've not had the time to add back yet. So you'll see that some experimental maps are missing. For instance, the initiative bar is not currently implemented. There are a few small things like that, but I'm planning to get back to those later on. So to those of you who are really far into your projects and don't want to convert because of all the work that's involved, I perfectly understand that, and I will of course continue to provide any support that you will need for earlier versions. If you're not that far along, I would consider switching to this. You'll just have to do the cost-benefit analysis yourself, just test it out. I hope that people will enjoy this. As I've spent a lot of work on this, I could probably have made a new asset in the time it took to make this update, but it's like, yeah, when I see that something can be improved, I can't stop myself, and I'm using this toolkit to make my own game as well, so I wanted to work as well as it can. And I mean, you might see some of the benefits to this already, but some of this might not be that obvious. Stuff has changed, but how does it affect my game and so on? And this is, and a lot of these changes are based on the sort of feedback and questions that I've gotten over the years, and realized, okay, this could be made more simple, this could be made more modular, and so on. So in many ways, this makes many things more simple, and it means that you will have to rely a lot less on sort of inheritance of actors and objects, and to be able to access features. You can swap out things like puppets, you can swap out pathfinding, you can use actions that are used in one actor, and you can use the same actions in another actor, because they are separate actors, right? So this is a through line, I guess, in all of the features that I went through now. Things that used to be contained within actors and objects, so you would need to use inheritance to use them, they can now be accessed through separate objects, and that opens up a lot of different things that you can do as well. So I am excited to see what you people are going to be able to do with this updated toolkit, and it's going to be fun for me to work on adding new features and so on, because just going through and adding back the various features in the toolkit now based on these new underlying changes, it hit me again several times how much easier it was to add many of the features that I had before, now that I had completed this refactoring. So I recommend doing stuff like, looking into things like, people never look into the Hydros layer map, the 2D map that I have here, and I spent a lot of time also refactoring this to work with the new system. So there's actually a lot of stuff in here. Even if you're not using a 2D, you're not making a 2D game, consider looking into it, because it has, picking up items and fog of war and lots of other stuff. And I've updated this map so it works with the new action system, it works with the new grid UI and so on, and also the jungle raid map and so on. A lot of changes. You can see here a new grid UI that's here, and you will find actions, or one action here within the advanced map. So there's more of that within the example maps as well. So that's it for this time. So I'll be making more tutorials. Like I said, with the kid and all that stuff takes time, but I will be getting into more detail. And until then, like I've said a million times, just get in touch in the support thread or on Discord, and I'll see you there. And good luck on making great games.